Hello and welcome to Astronomical Revelations with Lenny Ravitz. Today, I want to talk about something that's been on my list for quite a while, but I just haven't gotten around to it. I don't think it'll take that long, but it's an important subject in the realm of what else? The universe. And things that our wonderful scientists and scientific community have been resting on for many, many years, not revisiting and not re-understanding or understanding the right way. And that subject is black holes. Okay? Black holes. I'm sure you've heard of black holes. I'm sure you have a general concept of what black holes are, or what you think they are, or what you picture in your head that they are. Some of that may come from visuals. Some of that may come from simply learning about black holes from professors or teachers. Some of that may come from your own inner logic, your own inner understanding of what a black hole is and or could be. But here's the biggest thing. Here's the biggest problem with the concept of a black hole. Okay? Here's the biggest problem. They aren't holes. Okay? Let me say that again. Black holes physically aren't holes. They're called black holes. They're thought about and explained of like as black holes by physicists and other people, but they physically and in any other capacity of the universe, they are not holes. What they are spheres. Spheres. Just like a star. These objects in our universe, the reason they have been explained as black holes is because when you look through a telescope and you gaze at the object in the sky, it indeed looks like a big black hole. Okay? Now, of course, when you're looking at it in sort of a 2D way, yeah, I think maybe the first predilection one has when looking at a black hole is that it's almost like this big 2D black hole, but it's not. It's a sphere. And I'll tell you why. And then I'll continue to attempt to explain why it was ever thought of or construed as or explained as a hole, when in fact it isn't. It's a sphere. So what happens is you have a star black hole cycle. And many stars, usually based on stellar mass, become black holes in the end because they've reached that critical enormous mass that they have to reach in order to begin the process of becoming a black hole. Some stars in their life cycle become planetoids, neutron stars, these sort of amalgams of the of planets, stars, those sorts of things. They're sort of they end up being an in-between sort of stellar object. Those things you can learn about. You can look into astronomical physics, life cycles of stars, things like that. Um, but what's important is that you understand the life cycle of a star. And I don't know if our sun is going to become a black sphere or not. Black hole, black sphere. Um, Maybe someone knows. I don't know. Who knows? Maybe it's going to become a neutron star. Who knows? Maybe it was before. But what happens with these black spheres is you have a sufficiently sized star like Betelgeuse, for example, not the movie, the star, which is an enormous star. It's, I would have to guess, but is like 800 times the size of the sun. Maybe I'm not, that's just off the top of my head, but it's enormous. I think it might be an astronomical unit, which is the distance between our sun and Earth, basically 93 million miles, is an astronomical unit. So it might have the diameter of an astronomical unit. I don't know. It's just a guess. But anyway, a supermassive star like Betelgeuse becomes a black hole. This is the theory anyway, because of its enormous mass. And as you know, if you've listened to my other podcasts, gravity does not exist. But they would say that what happens is the star, over billions of years, is using up its fuel, expelling all that heat. And then they would say that the gravity, so it expands as it's reaching its final life stage, as it's using up all that heat and fuel. But then what happens is once that fuel is completely burned up, gravity, they say, then sucks back the star, the stellar mass, in the catastrophic explosion in which a supernova is created. So it contracts down in a fraction of a second, this enormous object in the sky. And all that mass in a fraction of a second crashes down onto itself, and it causes another enormous explosion called a supernova, which is the brightest object in the sky, where all of that mass then explodes out. It creates these enormous temperatures, and the luminescences more than anything. And it cycles between supernova and it cycles between the expansion and the supernova, and eventually it becomes a black hole. It becomes a black hole because now we're beyond the supernova, and now gravity, okay, this is the theory. Gravity is so intense with such a huge amount of stellar mass that it crashes down upon itself into an infinitely dense point called a singularity. And this is an infinitely dense point called a singularity, in which it's so dense and so massive that nothing can escape its gravity, not even light. Okay? And this is the theory of the black hole and how the black holes come to be. And then continuing on, talks about, the theory of right now, the common knowledge of the theory of black holes, and this singularity, in essence, is the core of the black hole. And then what you have is basically this singularity, which looks like a black hole, and not even light can escape it, and it has such a if the Starship Enterprise, right, from Star Trek, is going close to a black hole, actually the particles will be stretched out like spaghetti because it's so strong that even the front of what's going towards a black hole is sped up to such an extreme relative to the back that things are stretched out like spaghetti and all this sort of stuff. And a lot of it is true. And there's a lot of truth to it. Theories, by the way, a lot of these things are impossible to test. You know, how can you test something that light can't even escape? All right? But here's my theory of what a black sphere is and the life cycle of a black sphere. Okay? I don't think that there is any such thing as a singularity. And I don't think there is any such thing as a black hole. What I think, or black holes, what I think is that, first of all, the only reason that the term black hole was coined, again, was just a purely visual reason. Not a physical one, not one based in reality, purely visual. So, astronomers looking through their telescopes at the sky, gazing for hours and hours, and what does it look like? Well, the best thing to describe it, it just looks like a hole. Now, it looks like a hole because indeed it is